Once the Gaussian calculation is complete, a window will pop up telling me that Gaussian job has completed, asking me if I want to close the Gaussian window. I click yes, and another window appears asking me which file I would like to open. So let's choose first to open the log file. Click also on File Open Options and make sure that Read Intermediate Geometries is checked. Then click on Open. So now on the left, I can see the results of my calculation in Gaussian log file. You can see that I have 8 geometries here, so I can step through them. Number 1 is my initial geometry, and then it's a geometry during structure optimization in second, third, fourth step, and so on. I can also click on the green circle here, and you can see how the structure has changed during the optimization. You can do the right click on the background and go to Results, Optimization. So this window is going to show you how the total energy of the system changed with each optimization step. So overall, what you would like to see, that you end up with a lower energy at the end of the optimization than when you have started. Also, since we have done the frequency calculation, we can check our calculated frequencies, which are going to tell us if we have optimized the structure into an actual minimum. To do that, do the right click, go to Results and Vibrations. What I'm looking for in here is that all of the calculated frequencies are positive, that I do not have any negative or imaginary frequencies on the list. So all of the frequencies are positive. It means that my structure is at a local minimum. I can also animate the frequencies, which can be a fun thing to do. So for example, I choose mode 1, you can click on Start Animation, and you can see the normal mode that corresponds to this frequency. Okay, so I can also go to 6, okay, which is the asymmetric hydrogen stretch. Okay. Since I have calculated frequencies, I also have the vibrational spectra available, and I should be able to display them by clicking on Spectra here. Okay, so this is my calculated IR spectrum. So here I can close. Another important thing to know about is the summary of the results. So you can do the right click, go to Results, and click on Summary. So this gives you the summary of your calculation or the overview. So the calculation type, it's showing me frequency because this was the second step of the calculation. This is the methodology, basis set, charge, spin. I did not use any solvation model, and here is the total calculated energy of the system. So here are some useful things that you can glean from the log file. Next, let's open the checkpoint file. So click on OK. I can close the log file and go to File, Open, and click on the checkpoint file. So for the checkpoint file, I also have the summary available. So I can go to Results, Summary. I get the same type of information. But the new information I get from the checkpoint file are the molecular orbitals. So let's see how we can display them. Do the right click, let's go to Tools and select MOs. That will bring up a new window. On the right of this window, I can see a list of the molecular orbitals with orbital energies. They are ordered from the lowest energy to the highest energy. and I can display them. Also, you can see the occupation of the orbitals. So number 8 is my highest occupied molecular orbital, that's doubly occupied with a spin up and spin down electron, and number 9 is my lowest unoccupied molecular orbital. So let's display them. Click on Visualize and then click on Update. And this will create pictures of orbitals for the ones that are highlighted in yellow. So this is my HOMO. You can see that this is a pi antibonding orbital between the carbon and oxygen atom. And the LUMO is another pi antibonding orbital between carbon and oxygen. Sometimes it's easier to look at orbitals when I make them transparent. You can do that by doing the right click, going to View, Display Format, click on Surface, and then choose Transparent Format. Click on OK. So now I can more easily see the location of all my atoms in the drawing. If I want to display more orbitals, I can highlight the ones I want to look at in yellow and again click on Update. So for example, this one, number 6, is a sigma bonding orbital between the carbon and oxygen atom. Sometimes it also helps to adjust ISO value. Sometimes you find that going to higher ISO value is going to give you a little bit clearer picture. So I can change the ISO value and click on Update, and it will update the ISO value for those orbitals that are highlighted in yellow. So these are some of the basic things that you can visualize in GaussView for your log files and the checkpoint files.